Let's talk about arrays. Arrays are important because at some point our variables are just not enough. We could go ahead and create many variables infinitely, but our application is becoming static. It's set a specific number of variables for a specific task required. But in reality, or in the real world, it's never so obvious. Every time changes, everything changes. It could be many, it could be less. A great example would be as a teacher. Sometimes I have 20 students, sometimes I have 40, sometimes I have 120 students. So we need our application to adapt to the amount of values we require to store in the memory. Okay? And we can't just go ahead and create, let's say as an example, if I wanted to store the grade of all my students, I can't just go ahead and store grade student 1. Let's say you failed. And then I have to repeat this many times, right? And then go ahead and change this. As an example here, we got 9 students, but it becomes problematic in a couple of reasons. The first, I needed to create that many variables. Second, I need to name them specifically every time I want one of these variables. So I gotta say grade student number 3, grade student number 6. I can't just go ahead and go through all of these willy-nilly. I can't just do whatever I want. That's the first problem. The second problem is, what if the next time I run this application, I don't have 9 students, I have 160 students? Do I go and create 160 variables? I could, but remember our application is given to the user, and the user does not program. So we can't go ahead and tell them, hey, every time you need more variables, just call me up and I'll come there and create you some variables. No. So what we need to do is to make something that could adapt its size to the requirements or needs of our user. So rather than having grade student 1, 2, 3, well, let's say till 9, what we need to do is to create something called an array. An array stores more than one value inside the same variable name. So let's go ahead and create this and we'll talk about it. So what we need to do is, again, say the specific type. It could only be one type. We can't mismatch, at least not yet. Well, we're going to create one type. We're going to specify this bracket thing, which specifies there's more than one value. Oops. And then we're going to create the variable name. And this is important. When you create the variable name it something that's plural. So if you have another developer in your team, he understands that this is an array. So here I could say students grades, or I could say student grades, but that would be one student. So I would like to say students grade. So a lot of students, plural with the S, grade. Now, I cannot set the value to one value because here I set the value, there's many values, but here I'm trying to make it equal to 45. This cannot work. Well, first thing first, we learned from previous videos, this is not a primitive type anymore. Why is it not a primitive type? Well, the size on our stack could only fit one integer. When we go more than one integer, well, we can't fit them anymore, right? Could it have, let's say 5, 10? Well, then that's 10 times 45 bits. 45. It's 10 times 4 bits. It's too many, too big of a size for a stack. So what's going on here? It's basically when we create this variable, students grade, we'll create it here. Again, on the stack, we'll put the variable name, students grade, and we have to put the value here as well. Let's go change color here. So the value cannot be 44 because we're storing an array of it, a bunch, more than one. All right, we could store only one as well, but it's no point. So what's going on here is we need to store an address here. So here it has to be an address. an address of where it is inside the heap memory. So inside the heap memory, it will go and find the space required to store our array. But in the case of an array, right now, it doesn't know how much of a size it requires. So we need to initialize our array with a size. So what we're going to do is surround this by curly braces, and we're going to put our values inside of it, spaced out by a comma. So for each value, we're going to put a comma. 45, student number 2 is 23, 99, and let's say 100. Okay? And let's say maybe a 0 as well. So right now, what we got here is we got 5 students. 1, 2, 3, 4, 5. So we got 5 times ints. Well, we talked about ints. They're 4 bytes. So in the memory, we need to do 5 times 4 to get a full size of 20 bytes. This is important. So on the heap, let's say the OS, or in this case, your Java compiler, whatever it is, we're not going to talk about that too much right now, is going to go find somewhere on the heap enough space to store 20 bytes. And this is important. The 20 bytes of space is really important. So this is 20 bytes. So it found enough space, and it's going to 1, 2, 3, and 4, 5. And it found enough space to store those 20 bytes. And in this case, it said initialize them with these values. So we got 45, 23, 99, 100, and 0. Now this address, this is important. This is how it's going to function under the hood. Let me change colors. So this address is actually pointing to the first element. Not even to the first element, to the initial location, the start of my array. And this is important. This is really important because how it functions, we could break it, or you could do more complex things. A great example of a future thing is if you wanted to hack someone, well, you'll find a leak and you try to get outside of our application. Anyway, let's not talk about that. So starting at that location, this initial location here, the beginning of it all, we got our first value, 45, at that initial address. Now, how can I go to the next address? This is what's interesting. You got to think about this array as if we were 5 roommates, right? We got 5 people. We got 5 roommates. And each of those roommates, they're going to get a room. And for us to know which room they are, we're going to use the size to determine where we are. In this case, the OS or your Java is doing this for you. But let's talk about what I mean. Basically, we got 45, and if I want to go to 23, I need to move this address by 4 bytes. It's simple as that. So if I do plus 4 bytes, my address pointer, my address over here, is going to move over here. And now we're talking about 23, right? If I add another plus 4 bytes to the current address, so plus 8 to the initial address, well, we're going to be over here, and we're talking about 99 now. And this is important to understand because at some point, we're going to reach the last one. And the moment we go a bit further out, we're going to be out of bounds. We're going to go in some other memory that does not belong to my array. In Java, this will give you errors, and other languages, this will not give you an error. Sometimes you could go in some other part of the memory and change things, and you will either crash your application or crash the OS. It's interesting, right? So how does this retrieving work? Well, if I want to retrieve a value, we're going to, let's say system.out, we're going to print it out. We want the grade of student 1. So I want the 45 right now. To retrieve a value inside this array, we're going to again call our variable. And this is not enough. So if I do it right now, there's no compile time errors, there's no errors. If I run it right now, it will function. However, the value that it gives me back is a bit weird. The value it gives me back is this weird string. The way I like to think of this thing, and I like to tell my students, again, with a grain of salt, we'll come back to this. The initial part is telling you what type of reference object it is. Right now it's saying it's an array with this little square bracket of integers. And this is the address of where it is inside the heap memory, right? So an array of integers in the heap address memory. This thing was supposed to give us back 45, but rather than 45, it gave us an address. Why is that? Well, we retrieved the value of the variable. The value of the variable is on the stack. The value of the variable on the stack is the address. So when we retrieve this, we retrieve the address and not the value we were looking for. For us to retrieve that value 45 for an array, we call this dereferencing. We're going to put brackets again and give a position. Now, this is an interesting part. The first position will start at 0. There's many reasons for this, but remember the thing I was telling you about the location of the array. And this makes it a bit easier to grasp. So let's run it. For now, we're going to get our 45 just to show, right? So we're saying inside my array, go at position 0, which is the first one. Give me 45. Well, give me whatever's there. In this case, it's 45. Now, I like to think about these positions. Let me draw again. So these positions will start at 0. Then it will increase by 1, by 1 every time. So our positions are 0, 1, 2, and 3, and 4. Inside the memory, our positions will determine where the address will be pointing to. So here, we're doing current address, so ADD, current address multiplied position multiplied size of the type size. So the address is always it's always going to be the same, right? Unless we redefine it. So the address is always this location over here in red, right? Over here. The position, it will go between 0, 1, 2, 3, and 4. The type size, well, it's not going to change. It's always int. So 4, 4, 4, 4, 4. And this is wrong, sorry. This should be plus. So what we're doing here is we're doing position times type, which will add towards our address. So position times type, we got here 4. Here we got 0. So we're at the initial location. Here we got 4. Here we got 8, 12, and 16. So this is 0, 4, 8, 12, and 16. So if I want to get any of these values, I need to know the location it is, because that's how it's going to figure out where the position is. It's going to do position times the type, and it will give you every location you need. And what we do, well, what the computer will do, it will read the next 4 bytes, right? It will read the next 4 bytes. So in this case, the first 4 bytes gives you 45. Remember, we talked about this when we were talking about types. Even though we're given 4 bytes, we don't have to utilize all of those 4 bytes. So it could be that we only utilize a few of those, but all of that, all those 4 bytes are reserved for that integer. In this case, it's all reserved for that array. And this is important. Why is it important? Well, let's clear out our screen for a second. It's important because what happens if I go over that maximum of 16 bytes? And in some languages, you could do really nice manipulations, such as, let me bring that back, such as C++ and so forth, so on, but we're not there yet. So what happens if I try to take the grade of, let's say, position here, even though we wrote 1, remember that the user doesn't understand 0, all right? So the first position makes sense, then position 0. For the user, that makes no sense. Student 0 compared to student 1. Okay, just remember that. It's a bit confusing, but for the user, he doesn't know about 0. Okay, but let's make it just not confusing for us. Let's say that was position 0. What if I want to get position 5? And I do student grades at position 5. You'll notice here, we're getting a little warning. And if we put our mouse over it, it's going to say array index out of bounds. What happens is now we're trying to access somewhere outside of the heap memory. And you could see here, we get a big exception error. We'll talk about these errors later. Index 5 is out of the bounds of our array, which is of length of 5. Remember that the location starts at 0. So 0, 1, 0, 1, 2, 3, 4. The last position is 4 and not 5, even though there is a length of 5. And we get these issues. So this is something important to remember that's going to happen a lot. Okay, so our size is always -1. Let me erase a little bit. Let's play around with this a little bit. Now, the first cool part is we learn enough that we could iterate through this array. So int position equals 0. Position is less than 5 plus position. And inside of that, we could just go ahead and print out student, let's say position plus and we're going to give the grade. Students grade at position. Let me clear my screen. This is pretty cool, right? Having an array, it's pretty awesome. One problem we get from this is, what if our array changes? What if now we do 34? And let's add a few more just so it's a bit more interesting. You'll notice that our array is our for loop is not adapting to our array. So the cool part about arrays, they're kind of special. They're not primitive types, they're reference types. So there's a lot of helper functions given to us. These helper functions enables us to utilize the array better. So rather than specifying 5 here, which is not true anymore, what we could do is give it the size of our array. So student's grade, and notice that the IntelliSense will just put it up for you. Student's grade dot length. So this is a built-in functionality of arrays. So we specify the variable dot give me the length. So for that variable, give me the length. This is what the dot is for. So now if our array changes size, it doesn't matter because it will always take the length, and we're saying our position needs to be less than the length. So in this case, the length is 8. Our position starts at 0 and goes up to 7. So these helper methods or functions are really useful for us. All right. So here we've done a couple things. We've declared our variable, and then we initialized our variable. This is the first method, or the first way that we could initialize an array. Another sort of way that we could initialize an array, one that's utilized more often, is not by doing this curly brace, but it's by the new keyword. The new keyword creates a new object on the heap memory. It initializes or creates that memory location. How should I say this better? The new keyword on the heap will create what we need to be able to store values in there. Okay? And in this case, we have to specify what we're creating on the heap memory part. So we're creating an integer array, and we have to specify the address. We have to specify the amount, the length, the length, the amount of integers that we require. Why is this important? Well, we talked about this. This is important because on the heap, it needs to find enough space to store what we need. So if over here, so actually let's go ahead and let's say over here there's something running. This is my Chrome, this is my Firefox, this is my other stuff, blah, blah, blah. And inside of that, let me go here. Inside of that, we say we have a size of 10. Well, now this is not going to function. Why? Because right now there's stuff here. So if I keep expanding on it, it will break. We're going over the memory of something else. We're erasing something for us to keep going. So that's not how it works. What happens is this gets erased, and it will go look for a size of 10. How do we know the total size? Well, we know it's integer, so it's 4 bytes. We need 10 sequential values right beside each other. Why sequential? Well, because we need to go to the next one by adding 4 bytes. So this is important. So again, let me erase a little bit. So we need 4 bytes, and we need 10 of those sequentially. So we need 40 bytes, that space allocated to what we need. So here is not enough, here maybe not. So maybe over here I have enough by doing 40 spots, by getting 10 spots, 40 bytes. And it has to again be sequential. Otherwise, when we do the +4 and the continuation is here, well, then we're messing up. Okay, so this is important. So we always have to specify the amount that we need. All right. So what would happen by specifying the amount we need? By specifying the amount we need, we could gather those data at any moment later. So right now, if I print this, let's run our application. Right now, if I print this, you'll notice that all of those integers are initialized to the default value of an int. And it's not a good idea to use the default value because sometimes it could be different languages, different OS, it could be different. Let's not make our assumptions good. It's not a good idea to follow assumptions. It's better to initialize the values to a value we're confirming, so that between one OS, one compiler, one whatever, it's always going to stay the same. Okay? So this is not a great idea. So let's make this a little bit better. So how about we ask the user, so we're going to bring in the scanner. Oops, I can't spell anything. I'm going to bring in the scanner, and we're going to get it from the system.in. We're going to ask the user, oops, having a hard time today. In this case, let's say it's a teacher. How many students? Okay. And he's going to enter the amount. So int total students. And we're going to say scanner, give me the next int. Now, in this case, I'm creating the variable after I got this. So here, rather than saying 10, I could say total students, right? Pretty cool. Now, we need to get those values from the user. So again, we create another for loop. We create int position 0 position less than our student's grade dot length, right? The same code as down there. My computer is frozen. There we go. I'm going to ask him one by one for each student. So please enter grade for student. And here we're going to add position. And we're going to add a little colon. And we're going to get that grade. So we're going to say student's grade at that position equals scanner.nextSense, right? So the same way that we output by saying student's grade at a position, we could also input, we could also assign a value by doing student's grade at position. Let's go run it. And we're going to make it a bit more complex. So let's say right now I only have 3 students. Please enter grade for student 0. Again, this 0 is a bit hard for users to understand what that means. It becomes confusing why you started at 0 when normally in life you would always start at 1, right? So what we want to do is kind of fake this information to become 1. So here, this part where we're outputting the position 0, we're just going to say inside parentheses plus 1. What this does is we're not changing the value of the position. We're not assigning a new value to it. All we're doing is whatever the current value is, just add 1 to it so it's a bit more readable to the user. So we're still assigning at position 0, but the user will see position 1. So let's say over here we have 64, 100, 32. And when we print, notice that when we're printing over here, notice we get 64, 132. Hey, that's good. And again, let's make it a bit just more complicated to have some fun. We could say, do this, right? While student's grade at position, and we could now enforce that the entered value is between 0 and 100. So if it's less than 0, right? Or student's grade position, we're doing the inverse so that this loop does it again continuously. Or if it's bigger than 100, I want you to ask this question again and again for the same position. So this inner loop must finish before the outer loop, right? Let's go ahead and try this again. How many students? 34. No, let's not do that. Let's say again, let's say a new number, let's say 5, just to have some fun. So over here we give 15. This one, by accident, I do minus 52. Notice that it comes back. We're asking the same question. 64, 99. Let's say I give 233, same question. 100. And let's say last one, we try our edge cases. 101, not working. Minus 1, not working. And I give it 99, perfect. Right? So 4 students, 15, 64, 99, 100, 99. Cool. Now, so there's 2 ways we could initialize this value. I think we went over everything. We gotta remember how it creates these things. Make sure that we don't go outside of it. So make sure that we utilize given variables or given functionalities that our arrays have, such as this length. We could access them one by specifying a position. We could also assign them by specifying position. Both cases will need to do that to be able to either assign or read from it. Now, there is the rest is fine. We're going to come back to this in the future, but arrays, again, it's important. Remember that our variables need to be plural. Over here. So students grade. This helps out others when the code becomes really big and when they're accessing a variable to understand that that variable is an array. This is cleaner code. Other than that, I think we covered everything I want to cover for beginning arrays. I'll see you guys in the next video.